Hey, Steve Baczek, architect. I am out at OKNOPLAST Windows. Yes, I am somewhere just outside of Cracow, Poland. Just arrived, made our way out to OKNOPLAST. Now, you might be familiar with them, you might not be familiar with them. They are a window company in Poland. They've been in operation for over 30 years. They're in 21 markets worldwide, 3,500 different distributors worldwide. But one of the most astounding numbers, I think, that really kind of caught me off guard was 2.3 million window units they make a year. What does that translate to? Somewhere between 6,000 and 7,000 windows a day are being made by OKNOPLAST and being sent out across the country. One of the people that we're going to be taking this tour with is a gentleman named Tim. And Tim is coming, he's our US OKNOPLAST representative. And we're going to bring you all the insights from how the windows get started to the final wrapping up and preparing for delivery. Tim, why don't you join me here, buddy?
Welcome to Poland, welcome to OKNOPLAST. How are you, sir?
So, OKNOPLAST, I know they've been in Poland for over 30 years, but
yes, sir.
Let's talk a little bit about OKNOPLAST US.
So OKNOPLAST US, we started in about 2018 into the US market. We've got about 40 to 50 dealers roughly in the US. So typically anywhere you are within the US, we can put you with somebody very knowledgeable, very educated in our windows and doors. And focusing really on the tilt turn into the American market.
And a lot of these distributors in the US have showrooms. So if homeowners or architects, they want to go and they want to open and close a tilt turn window, they have those opportunities.
Yes, sir, absolutely. I mean, we are all hands on deck. We are not happy till the customer is happy in a project. So when it comes to reaching out to architects, we really try to reach out to them to offer lunch and learns and many different possibilities for somebody to really get educated on a European window.
And being a European window and selling and utilizing them in the US, one of the questions as an architect that I get a lot is, well, they're European, I'm probably gonna have to wait a really long time to get these windows from Europe for my project, but that's not true.
Well, yeah, I concur. We're about an 8 to 10 lead week on a UPVC product, about 10 to 12 max on our aluminum products.
Right.
So, you know, typically we're ranging around the same lead times as an American product produced right there in the US. So don't hesitate when it comes to lead times and getting your windows. We can definitely fulfill that.
Yeah, and I'm sure all of your distributors, you know, they can certainly help guide it. One of the guiding principles that I use when I'm working with builders, especially for the first time using a Euro window, I say, as long as we get those windows ordered about the time we're digging the foundation, then they're usually timed just about right, that the frame is up, the rough openings are prepped, and we're ready to use those windows.
You know, I agree, Steve. Roughly when you put the footers in the ground, it's time to order windows. The good thing about us is a lot of people are hesitant on the logistics. Logistics is hard for people to understand. We do use a US-based logistics team. So from the ground of the US, they handle all your shipping from our door to your job site or the dealer.
Yeah, and one of the questions that I get from builders also is, you know, when they talk about logistics, they're saying, well, it's coming all the way from Poland. But when you realize, okay, even if these windows were made somewhere out west, they're getting put on a truck or a train and they're coming across the country, where getting put on a boat somewhere in Germany and coming across the ocean, it's really not very much different logistically.
Right, it's like your windows traveling on a cruise ship. You know, it's kind of like a nice, enjoyable ride before you get your windows.
All right, so we're about to head in there, but
yes, sir.
And I know you've been to the factory, I haven't.
Yes, sir.
But I'm gonna give a little teaser. I'm gonna ask you to give the crowd a little teaser here. What's the one thing that I should be really excited to see here?
I think you'd be really surprised by the size, the magnitude of the glass. A lot of different variation and the 16 automated lines. I mean, it's really surprising when people see the automation that's done inside the factory.
And this is just one of 6 factories, and this one is 50,000 square meters?
About 51,000 square meters, roughly on over 30 acres of land.
Yeah, and the difference here that I'm really excited about is past window factories, they always make the IGUs. For those of you not in the industry, it stands for insulated glazing unit. That's where they actually put the glass together, seal it, get the gas inside between the panes. Those are usually made somewhere else, trucked here.
Correct.
But those get made here.
Absolutely.
So we're going to be able to see the IGUs get made. The IGUs get placed in the sash or the frame, and then the sash, if it's inoperable, gets set in the frame.
And you'll see the automation lines where it all come together, the sash and the actual window extrusion.
Yeah, so stay tuned. Let's go see how they get made. We're in a large building. I see some glass. Talk to me, where are we?
Yes, sir, Steve. We are at the Jumbo Glass Storage.
Jumbo Glass Storage. Now, I'm always leery of when people say jumbo, because jumbo means a lot to a lot of people.
What we're talking about here, Steve, is 6 meters by 3 meters of glass.
6 meters by 3 meters. So if I do that quick computation or calculation in feet, we're probably talking somewhere in excess of 18 feet and probably around close to 10 feet.
That is correct.
About 180 square feet of glass for each piece.
Correct.
And you can see here behind us, that is not a small piece of glass.
No doubt, Steve. I mean, it's monstrous glass. We're able to capture 4, 6, 8, 10 millimeter glass in our glasses. We have insulated glass up to 6, 8, all the way up to 12.
Right. And you also have laminated glass here.
We also have laminated.
They call it VSG, which
VSG here in
I'm
Poland.
not quite sure exactly what that means, but it's basically laminated glass. Now, one of the numbers that really kind of hit me was when we were talking to the window manager here of this section, 80 different types of glass.
80 different types of glass, Steve.
That's a lot of glass to manage at this size.
Correct.
Right?
Correct.
And you have privacy glass, obviously, different films on it, because this already comes with whatever films or solar heat gain coefficients. All those numbers are already attached.
Correct.
To these pieces
and
of glass.
Each one of those 80 different window types plays a factor into your efficiency numbers.
Exactly.
When choosing the proper glass for your project.
Later, when we're in the factory and we'll see the IGUs, that's insulated glazing units, actually get made, you can't apply sealant to a film. You have to apply it to raw glass.
Correct.
So not only is this stuff kind of the machine CNC going around, whizzing around, cutting, it's actually grinding on the one side or both sides of that cut.
Correct.
So that later when the sealant gets applied, it's getting applied to that raw edge.
Yes, sir. Yes, sir, you're correct.
I don't know about you, I mean,
I'm excited.
This is certainly a hall of glass inventory here, but I'm excited to go see us.
This is one of many, and let's do it.
So
let's head to the next one.
Let's go check it out. So Tim, one of the most exciting parts of the IGU operation is actually cutting the glass.
It is.
I love this part because it's this machine that just zips around in a robotic fashion.
It really is fascinating just to see the operation, how it works. Literally 5 minutes or so, you're gonna see an entire glass project come out this machine.
What you don't realize is, you can see behind me, there's a whole bunch of numbers on this panel. So what happens here is, you saw the glass get put down on the table, and certainly correct me if I'm wrong, but there's a whole computer system here that OKNOPLAST uses that optimizes how that glass gets cut.
Yeah.
And so all this coding, which is pretty much Greek to me, right, is it's identifying there's certain pieces of glass for certain projects, but it's also cutting it so that we minimize waste.
It does, Steve. I mean, it all starts from your quoting your project upstairs, gets in these numbers and put through the system, and each department that we have visited, all the way down to cutting, after the cuts, gets organized and into the next stations, but everything is efficiently automated.
Right, and it's optimizing it in such a way, if we take a quick peek, that's the dumpster for the cutting table.
Correct, that is the waste. That is the waste.
So you have all of this inventory in these large pieces of glass, and then we have that very small dumpster that's handling the waste. And I say waste, my guess is it's not waste. It's probably getting recycled somewhere.
Correct.
And it's going somewhere to be reused again as another material.
That is correct, Steve.
You can see the glass is coming down. I can see that it's cut. I can see that it's ground on different pieces. And you can see there's a horizontal piece over there. We're gonna back away, let these guys do their job. And it's amazing to me how little effort it takes to basically snap that glass. So you have the one piece and you know, he does a little jig with it and you can see those snap because that grinds that glass. And you can see here that not only is it cutting the glass, but it's grinding that edge. So you can see, and it helps that this is a air assisted table, right? It takes little to no effort to throw these in. And you can see, literally, he just snapped that piece off and they're throwing it in there, but 180 square feet, he just snapped off a 1/2 inch piece.
Right.
And that's pretty much the waste product from these windows. And there you have it again, seeing that. And then these guys are stacking this all, basically depending on what project. Now, we sit here, I'm sure they have a system where everything is easily identified. They look at the numbers, they look at the carts, all of that stuff.
They do.
Fascinating part. I don't know. We head off to the next step.
Let's check out
some
the
more of
next.
this.
Absolutely.
All right. Some of you know, as we build buildings, some of the windows need to be tempered,
Correct.
right? There's a whole bunch of locations, bathrooms, doors, hazardous areas, glass that's close to the floor. The code, in America anyways, they have very certain requirements about tempered glass. Now, we talked about it over at the cutting machine that the glass is not only being cut, but the low E coating is also being ground away. But that doesn't stop when we have to move towards a tempering process. So we have the oven, for lack of a better term there, where the tempering process is going to happen. And we're going to go over there and talk about it. But I think before we talk about that, we can kind of show the beginning. And then we're going to do like a, I won't say a magic trick, but we'll put on a little show here for everybody to watch. But this machine is very important that I learned. When you temper a piece of glass, you really want the edge to be a slightly smaller dimension than the center of glass, right? So this one just basically came out of the machine. And if we measured it in, say, microns or, you know, very small numbers, the thickness of glass here versus the thickness of glass 2 inches in, it is slightly different, the edge being thinner. And the reason for that is when it goes through the tempering process, if it was the full thickness to the end, it would break in the tempering process, which is pretty interesting that it has.
We temper certain projects. We also do, we like to do in the US, if it's up to a certain elevation, we like to temper the whole house.
Yeah, I think you said 2,500 feet.
Yeah, roughly we like to be over 5,000 feet of elevation to fully temper a project.
Okay. So here we have a very long wall of a bunch of things happening. Down at the end is the first grinding station. So this chamfer that I'm talking about, it's not being cut, it's actually being belt sanded.
Right.
Right? So basically just taking the edge off. So the first station over there is taking care of three sides. And then it migrates down. We have another station here where the belt sander's only at the bottom. And it grinds the bottom piece. And then the last series of doors is basically the car wash.
A glorified car wash for
it's
your
a glorified
glass.
car wash. So when the glass comes through here, this is been scrubbed, washed, dried, and it's ready to go to the oven.
It's ready to go.
All right. So are you ready?
I'm ready.
Are you ready for the show?
Are you sure you're ready?
I don't know about this. So they say it's not going to break. Now, keep in mind, I have my 180-pound frame that I'm going to put to the test here. All right?
And my 6'6" frame.
Have you ever seen Indiana Jones in The Last Crusade where, like, you have to do the step where you believe? So they tell me that tempered glass is 5 times stronger than regular glass. And I trust, you don't see him on camera, but there's a gentleman here, Jonas, that I've just now put my life into his hands, and he has promised this will not break. So let's do it, Tim. This is tempered glass, and yes, my 180-pound frame on this tempered piece of glass.
Should we do a dance, Steve?
I will say I'm shaking in my boots right now, so I don't think we need to dance any. But here you can see that the tempering process, I mean, between the two of us, 160 pounds, maybe another 100 pounds.
Yeah,
so we got 260 on the center of this glass here, doing a little jig, a little bounce, and it's not breaking. Yes, you see it here. We're out at OKNOPLAST testing their tempered glass. So
Trust our glass.
Trust our glass. There you go. Let's head on over to the oven and see how this actually happens. The real process or magic is happening inside this
Right
machine.
here inside this oven.
Right. So like all machines of today, we have the computer controlling it. Right. So the glass comes off of there. Literally, the gentleman walks about 3 or 4 steps, puts it down on here, and it goes into
right in.
what I call the tempering oven. And it's
650 degrees, it will run through there.
but it's 650 degrees Celsius.
Yes, 650 degrees Celsius,
Right.
1300 degrees Fahrenheit.
Yeah.
For a
so,
range around 4 minutes.
So we're not going in there to get a tan.
No,
you're going to get one hell of a sunburn if we
Yeah,
go in
we're
there.
already sweating
So we wanna
standing
make
next
sure-
to it.
Yeah, it's already hot in here. So, but 1300 degrees, 600 Celsius, and it's in there for how long?
4 minutes.
4 minutes. It comes down, gets cooled, and we have tempered glass.
That's it. And then
It's
you get what we just did.
Yeah. You know, one of the fascinating things that I always find about this, and it's probably not any easy answer, but for years, like, how did we get here? How did we know that grinding the end is going to save the glass in the tempering process? Like, imagine how many pieces of glass got broke or what we had to do to identify that. And I guess the point I'm getting at is, you know, we're out on the job site, windows get delivered. There's a lot of things as the architect, as the builder, as the homeowner that we just take for granted. And we say, hey, here's a glass. Oh, it's tempered. Well, that means it's not going to break.
Right.
But there's literally years and years of research to make that tempered glass. Like, how did we know that the optimal temperature is 1300 degrees to temper a piece of glass? How do we know that it's 4 minutes that it has to run through this machine? How do we know that it has to get ground? My point being is, as homeowners, architects, and builders, you're out on the job site. You take a lot of these things for granted. Oh, yeah, they're just building, triple glazed windows or doing whatever. But understand, behind all of these products that OKNOPLAST and companies alike are putting out are years and years and years of innovation, research, failure to find success, right? So that when we're bringing the product to market and we're putting an OKNOPLAST window in your living room, you not only have the confidence, yeah, it looks like a pretty good window, but this is a window that has years and years and years of engineering, experience, failure, technology, computerized optimization, that we're bringing you the very best product that we can bring today.
Absolutely, the very best.
All right, so we've seen a lot, but all we've seen up to now is we've gotten glass from these big pieces. They're cut down in the small pieces. Now we have to actually make the window that you see, which is the IGU, insulated glazing unit. Yes, whether you're buying double glazed, triple glazed, or quad glazed, all of these panes of glass are going to get manufactured in such a way that they get sealed as a unit that will become part of the windows. So we're moving into kind of the front half of the factory, and they have 3 different IGU lines. They have one on the far side there, one on the far side there, and those 2 primarily take care of small to medium sized pieces of glass in a perfectly rectangular or square format. This larger line in the middle here, this is where they handle larger oversized pieces larger IGUs, as well as some of the ornamental glass. You can see here where we have 3 panes of rounded top glass that's obviously set to make an arch top window. So I think Tim's over at the IGU line over here. Why don't we go over, we'll catch up with Tim, and we'll talk about how we're gonna put all these together. Hey, Tim.
Welcome back, Steve.
Yeah.
Good to see you.
So, I just walked, from over there trying to catch up to you guys, and it's amazing how many racks of glass and stuff, like the amount of organization in this system, and talking to him, a couple thousand IGU units made every day.
It's wild.
So
just think of what really goes into a window package as a whole. All this that we've come through so far, it definitely is fascinating.
I remember the very first time I was brought to a window factory and learned, when you see an IGU, you guys see 3 pieces of glass, you see the sealant around the perimeter. I always had in my mind that they just stuck a needle in and injected argon or krypton or whatever the gas inside it. But that's not true.
No, sir.
Right? That these pieces of glass, this gentleman, he takes these spacers that have that sealant on it, and we'll walk up, we'll talk about that. But he basically applies the spacer to the glass. If you're making a triple glazed window, those 3 pieces go into there. That machine is responsible for displacing the 3 pieces of glass. It evacuates the air and fills the chamber with argon. And then when it basically comes together and compresses
it's argon filled.
It's argon filled. So there's no injection process, it's an encapsulation process.
Correct.
Very fascinating process here. I say we go to the end.
I say we'll
get that final seal on the IGU, and then we can follow those IGUs over to the other
factory. We
factory
follow it to the next phase.
and start looking at some windows.
That's it.
All right, let's head on down. They made the IGUs, they come out here. This gentleman here, he's putting tags and stuff on there, but there's that one last big step to IGUs. And that's basically sealing the perimeter of the unit.
Sealing the perimeter.
Right? And we have some examples here. You can see where we have those outer pieces and the inner piece here and how it's all sealed up. And that's basically what's happening on the machine right here in front of us, is the perimeter of that is getting traced with a very generous bead of sealant.
Correct, Steve.
From this point on, the glass never gets touched by hands again. Right? It's all kind of vacuum machines that are grabbing it, and then they're moving it to these racks, and then these racks are going to make their way over to the next building, and we're going to make some windows.
And then we're going to make windows.
So I don't know about you, but I want to go see some windows.
I'm ready.
In the maze of glass, I seem to have lost Tim. I'd say I could look for him, but he's probably hiding somewhere relatively low. But as you can see, it looks like mayhem here, but I'm sure they have a very good systematic process where all of these windows or all of these IGUs are soon to become windows. And as we walk through this, again, another fascinating trip, seeing how all of these IGUs get made, how all the glass starts down at the end as these large pieces of glass. And you can see now each one of these have a specific call out, specific project, and these are all destined for some window frames and for some sashes that we're going to see how they get put together in the next building over. So why don't we head on over there? That's it for the glass building. Let's go check out how windows get made. I know it looks like I'm on the back of the building. That's because I'm on the back of the building. I know this looks like a door that's pretty obscure, like Steve's supposed to be taking us on a tour of the window factory. Yes, I am. I'm about to show you something that when I talk about cutting edge, this is at the edge of window production, looking over the cliff at what other people or other companies are hoping to get at. So, it's very, very dangerous when Steve gets the key to the back door. So, We're gonna open up that door, we're gonna go inside, and I guarantee you are just gonna be totally amazed, as I was when I walked in there and saw what I saw. Absolutely unbelievable. But let's go in and we're gonna check this out. I'll see you inside. Absolutely incredible what we're about to see. So I'm told this is like the only facility in the world that has this level of automation in their storage, in the window industry. So what you're looking at on the other side of the glass, and believe me, I tried to get on the other side of the glass, it was a definite no-go. No people are allowed over there except for maintenance. You can see there is a very large crane. That very large crane also has a twin down at the end of the series of rails. What you're looking at across the way where it says OKNOPLAST Group on each one, think of this as a giant filing cabinet, right? So down the way here on the right-hand side is the loading docks. So in come all of the different UPVC profiles, extrusions, etc., that will be used to make the windows. Those need to get sorted out and stored. So on the other side of this filing cabinet is where they actually make the windows. But to get the pieces over there, somebody has to go, or something, as represented here in this crane, it goes through this filing cabinet and it'll pull one of the boxes, put it on its carriage, bring it over, and you can see across here, and there's multiple of them down there, but there's 2 conveyor belts here where the crane will deliver that box to the conveyor belt and send it to the other side. And that puts the extrusions on the manufacturing side of this storage. Now, you're probably wondering, this thing goes down for a couple hundred feet. I'm told there's 1,800 units of storage in this facility, and it's fully automated with these 2 cranes. Now, when we first came here, this thing was zipping around. It seems to have taken a break, or there's no call for the extrusions. But what do you say? We're gonna head on out. We're gonna jump over to the other side and see what happens to these extrusions once they get delivered. You can see here, we had that slot. I have to be really careful because you see this machine here, if I stick my hand in that laser beam, it shuts down stuff. So I was told I can't go on the other side of these yellow lines. But you can see there, that's that opening that we saw from the other side of the storage facility. And those carriages that it pushed in are right here. So those carriages come in, and you can see this one's loaded up with a series of profiles that we have an overhead crane that travels across here. We've seen it moving around. And what it'll do is it's gonna pick up this carriage and deliver it to one of the cutting stations. And that's where we're gonna catch up with Tim. We're gonna see these profiles getting cut up and put together, manufactured, and at the end of the line, we're gonna be able to call it a window. So let's go catch up with Tim.
So what we're looking at here, Steve, is we're looking at these sashes. The sashes come on this automated 6-meter lengths.
Okay.
They're basically going to walk, they're gonna be automated through here. They're gonna go into this Shermer machine, which is going to drill your weep holes, your hinges, all your hardware is gonna go through this machine and be pre-drilled.
Right. And you can see it's just going through. There's, I don't know, probably a half a dozen heads in there that have different drill bits, routers, and it's just basically attacking this like a pit crew.
Attacking it.
And then that will get kicked out to the next station.
Yes, that gets kicked out to the cutting station. So it comes through here, goes into a cutting station, which will be cut your profiles. You could do 90 degrees, you could do 45 degrees, you could do different variations in there in the cutting.
Yeah, and those frames, you know, when we were talking about it on the table there, there's basically 3 different profiles, right? There's frame, there's sashes, and then there's muttons.
Right.
That are mullions. And those all are going to get cut on this line. So this line can adapt to whether it's a sash or it's a frame.
It can, and we have 6 different lines of this that operate to its full potential.
These get cut, and they obviously get kicked over there.
They get kicked over.
It's always interesting when you go to a UPVC factory and you see metal.
Right.
And you're asking, okay, why is there metal in a UPVC factory? And I'm gonna grab one of these and just lift it up. But basically, I liken this to rebar inside a concrete frame.
Correct.
Right? The concrete can only do so much work as concrete before it's required to have some assistance.
Well, that's the same thing with UPVC, Steve. You have to steel reinforce it. That's what these you're looking at here. We are, full steel reinforced UPVC product line. That's how we're able to, magnify our sizes and really get the sizes that aren't achievable in the US is by our steel reinforcement here.
Right.
And what you see here is the quality control. They inspect the weep holes, the hinges, the cuts, everything on the whole profile just to make sure it is fully to its full potential to send down the line to be welded and constructed into a window.
Gotcha. And that's the job of this woman here.
Yes.
Things come down the line here. She stands there and she's the one. And I find it really interesting that, we see a lot of these boards around where OKNOPLAST is basically saying, these are our standards.
Yes.
And this is what you should be looking for.
Absolutely.
Right? And this is what you shouldn't accept. This is what you can accept.
We try to hold ourselves to our highest standards.
Yeah. This is where the window, all 4 pieces get welded together and they start making the frame or making the sash and it gets ground.
Well, this is where they start dating. We haven't got to the part where they get married.
Gotcha.
But right now we're dating.
We're just dating.
That's it.
So I know they have a bridge. Why don't we climb up on that bridge and then we can see this whole process from above.
Let's do it, Steve.
All right.
Hey, Steve, so what we have here is once the extrusions are cut, milled for the hinges, milled for the hidden weep holes, things like that, it comes on the line here. And what we have is where all 4 corners get welded at one time on this automated belt. It then comes down the belt all the way down to here, what we're standing in front of, and it scrapes all 4 corners in one unit at one time.
One shot.
One shot.
Very interesting. Now, I was just talking to one of the process engineers that obviously sets up these lines, and he was telling me that 2 things. One, the temperature of those heat weld plates is probably around 250 degrees Celsius, roughly 500 degrees Fahrenheit.
Correct.
But he said it's not always the same. He said they're very, how can I say, specific to the profile being used. So the temperature there might fluctuate a few degrees, but it's based on the cross-sectional area of the profile.
Right, it has to happen that way because of course you don't want, melting of the profile, you not to get a good connection in the corners or for it to separate ever. And what you see here is it coming down the belt now after the welded corners.
Right. And the thing that's baffling to me is you can compute that obviously you have to overcut it slightly because you're going to weld it together, you're going to melt it, weld it together, so there's going to be a little bit of waste. But I bet if that window was 2.5 feet, 30 inches, we went down there and measure it, it'd be spot on 30 inches.
Spot on.
And it's just incredible that they can go through this process and basically overcut the unit to a point where when it goes through this welding process and this grinding process, that it in fact comes out a perfect size.
And corners is a big thing to people when their projects come in. Seeing raised corners, seeing gaps in there, we try to really eliminate that and stay ahead of the game when it comes to really figuring out those corners, because for some reason that's one of the first things people look at is to make sure that their window is solid.
You know what, as an architect, the question I'm going to ask, and I'm only asking it because I'm going to have clients that ask the question. Everything that we saw up till now is nice square, rectilinear type shapes. But
that's correct.
If I want to get that elliptical arch top or Gothic arch, Roman arch, barrel vault, angled top, or maybe what if I even came to you and said, I want to do a circular window out of UPVC.
I would say no more, we can handle it.
Say no more, we can handle it. Now, that is somebody I want to team up with regularly.
Absolutely.
Not somebody that rolls their eyes at me and says, oh, really, you want all that? I want somebody that provides solutions because, you know, a lot of us have clients that are asking them. And it's hard not to, you know, walk by this rack and not talk about it. So there's ellipticals here, very soft elliptical here, some arches here that are a lot stronger, kind of half arches, angled. So testament to your, hey, we can do it. You're doing it every day out here.
Yes, we are, Steve. And let's not get stuck on that we can do this in an operable, not just a fixed window.
So not just fixed, we can do a sash that marries up with this, and it will still carry all the air tightness requirements and everything that is standard with a rectilinear.
Yes.
Absolutely incredible. Well, it's hard not to finish this factory side without talking about this baby right here.
Yes.
So, and I've had some questions about, can you do a UPVC window in, you know, a full circle? So here's the answer to my question.
This is it, Steve.
And the IGUs, everything, they just fit in there. We can have mutton bars, the whole 9 yards.
SDL, we can do GBG, grids between the glass.
Testament to OKNOPLAST in trying to deliver the very best product that they can to my clients as well as your clients in America. They don't roll their eyes. They don't say, well, I don't know if we could do that. They provide solutions. You know, one of my favorite comments when I'm talking to my kids at work or just talking to people, for me, I like to keep things very simple. So there's two types of people. In this case here, I'm gonna say two types of companies in the world. Those that talk about doing and those that do.
That's it.
And when you walk in a factory and you see a circular window, I can't walk out of that factory and just say, that's a company that does. They're not talking about doing, they're not talking about maybe we could do a round window. They're building a round window.
We're a simple solution.
Simple solution. There you have it. Doesn't get much better than a round window.
That's it. All right, Steve, so what we have here is this is where our glass and our profile gets married. Okay, this is where the final product will come out of the factory. We've seen the jumbo glass, we've seen the IGU, we've seen the warm edge spacer come together, the argon, the tempering, we've seen the organizing of the profiles come into the factory, we've seen the drilling, the hinges. Now here is where the window gets married.
And I can see the gentleman behind us there, he's putting in some hardware around the unit for the tilt turn or whatever operation that is. This one already has the sashes attached to the frame. I can see we have the hinges there, and we don't have the stops here, which is interesting because I just saw the gentleman kind of setting these, and they put in all these spacers around.
Yes.
And my understanding is that these spacers are so that you can kind of equalize the pressure around the unit so that the weep holes will work.
Correct.
And the water will drain out.
Correct.
Right. If you wanted those gaskets up nice and tight, you'd create this kind of siphon effect and water would never be able to drain out of the unit.
Right. That's right, Steve.
So, and then as we go down the line, obviously you just see the window getting more and more. So here he applied the stops, and I'm not going to touch it, but I saw him hammering them in here. He had a little rubber mallet tapping them in.
And then applying the glazing bead.
And applying the glazing
product.
bead there. Well, what's interesting about this to me is that you can see just how simple that glazing bead is. Like the whole system is in there, it's airtight, but this just gets tapped in. So what does that mean? It means that should you ever have a problem, like the glass breaks, right? That client would simply get in touch with you or one of your reps in the state. They would then place an order for a new IGU. You don't have to get a new sash. You don't have to get a new frame. We just need a new IGU. And I know we haven't really talked about it, but I'm guessing all of the information, if I placed an order for my windows, you would have a whole file on Baczek's window order, and you could go to window 15 and the size of that IGU would be recorded in that data.
Yes, sir.
And so you could make another IGU, throw it in a container on the next shipment, pop these out nice and easy. Pop
And
the
you
new
know,
IGU in.
The best part about it, Steve, is if we do have a claim or something like that happens with a customer, we can air freight the glass here. We do not have to wait the 5 weeks for a container,
To ship it, we can
which
just
is
send
very
that
nice.
piece of
We
glass.
send that piece of glass.
Because it's really not that big.
Right.
Well, there we have it. One
There we have
ready for shipping.
That's it.
Right, we got the nice name front and center there. OKNOPLAST. So these, I'm assuming, go down here somewhere. They're going to get wrapped up. They're going to get taken over to a facility that we're going to go visit, where I think that's where you guys do all the sorting.
That's going to be all the organizing, the sorting, the packaging for the shipments is going to be in that warehouse. And it's
Got
a
it.
controlled environment as well.
And it's pretty much been a controlled environment the
Yes.
whole way. I mean, I'm still overwhelmed with the storage facility and how that is, all the material is stored to a very controlled environment there. I mean, it goes to show you the integrity of OKNOPLAST as a company trying to deliver the very best product that they can deliver.
Yes, I agree.
Why don't we head over to that one warehouse? We can wrap up this tour and we can talk about where everything's going.
Absolutely. Let's go, Steve.
All right. As you can see behind me here, literally thousands of windows, but that's what happens when you're making 6,000, 7,000 windows a day. You see all the little rectangles on the floor. We have designations 26, 27, 28, 29 up above. Now, what happens in here is the windows get made and here they get set for distribution, right? 21 different markets where these are going to get shipped to somewhere in the world, 3,500 distributors anxiously awaiting their windows to make their clients happy. And this is the last stop. But before we kick it out of here, let's go catch up with Tim. I seem to have lost him somewhere along the way, but we'll catch up with him because I think there's a really important aspect that we want to talk about with the windows and certification before we head out. So let's go catch up with Tim. Hey, Tim.
Hey,
I was
Steve,
looking
welcome
for you. I
back.
seem to have lost you. I don't even know how many square meters this distribution hall is, but this thing is massive.
Let's just say enough.
Yeah, it's enough. But we're over here. This is the section that these windows are headed to America.
These windows are headed to the US. Something we wanted to focus on here is certifications. All of our windows are NFRC certified, which is a big thing in a lot of states. Yeah. Some municipalities, some smaller cities, they don't require it, but just know that when you get a window from OKNOPLAST and it comes here from Cracow, Poland, it is NFRC certified. And basically you can go on a database, nfrc.org. You can look up any of our statistics on each window to make sure you really are getting a good quality window. There's no hidden agenda here. There's no full transparency when we sell you a window package for your home.
And a lot of that information, I think it's really important up front because in the design process, it's such that, a lot of our residential projects, we send off to an HVAC engineer to size the HVAC system, pick out equipment and such. Well, you can't design that system if you don't know what 20% of the wall being represented by windows and doors is doing.
Right.
And a lot of this information that's in that label is that information that's needed.
It does. And this is really good for, architects and things like that in the design phase as far as specifications, what they're trying to meet. Because a lot of these numbers don't really speak to the average homeowner.
Right.
And they don't understand, nobody would know a 0.20 versus a 0.26 U factor to where, we really try to drive to really educate the homeowner and educate the US and really understanding how much these values mean to someone's project or home and the longevity of it and the efficiency.
Well,
thank you, Steve.
I can't say enough. Thank you for joining me on this tour. Awesome to have, that second perspective. And obviously you've been to the factory a number of times already and to allow me to follow along.
Absolutely.
And,
wouldn't have it any other way.
And, no, it's all good. So I'm going to head on over here. We're going to close this out and I'm going to head home. All right, folks. So like all great things, they must come to an end. So that's the end of my tour here at OKNOPLAST. And you can see literally thousands of windows looking to go find their home. Now we have a couple projects where we've used the OKNOPLAST windows. They're getting made and they're going to get delivered. So stay tuned in the future. We'll have a whole bunch of videos on installing these on a couple series and a couple of our projects. So very excited to start using their product in a lot of our projects. So hopefully you enjoyed that. As you can see, literally thousands of windows heading out to multiple countries, including the US. If you want more information, certainly you can go to oknoplast.com and find out everything you need to find out about their windows, or you can get in touch with Tim, who is OKNOPLAST USA rep in charge, if you will, and Tim will either have the answer for you or he'll be sure to get that answer for you. So hopefully you enjoyed this. Like all of these windows and doors, I'm gonna go find my way home. So until next time, I'm Steve Baczek, Architect, and hopefully you enjoyed that tour.